The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program in the series CXC Mathematics in Focus. In this lesson, we are going to use the laws of indices to simplify algebraic expressions. Consider the term 4a to the fifth power. The number 4 is the coefficient of the term. A is the variable and is called the base, and 5 is the power or the index. Here are some of the important laws of indices. You are required or you're expected to memorize them. They will allow you to apply them easily when simplifying expressions. For all non-zero numbers a and b, and integers m and n, the laws are given with examples on the following slide. On the left-hand column, we have the laws. On the right-hand column, we have the example. The first one, a to the power m times a to the power n is equal to a to the power m plus n. In the example, 7 squared times 3 cubed is the same as 7 to the power 2 plus 3, which will give us 7 to the fifth power. In the next law, a to the power m all to the n power is equal to a to the power mn. The example to support that, 5 cubed all squared is equal to 5 to the third power times 2, which will give us 5 to the sixth power. In the next example, the law is saying ab to the power m is the same as a to the power m times b to the power m. The example to illustrate that, 4 times 3 to the fifth power is the same as 4 to the fifth power times 3 to the fifth power. The next law, a to the power m divided by a to the power n. That is equal to a to the power m minus n. The example, 6 to the fourth power divided by 6 squared is equal to 6 to the power 4 minus 2, which will give us 6 to the second power or 6 squared. The next law, a to the power 0 is equal to 1. The example given, 10 to the 0 power is equal to 1. Any number raised to the power 0 is equal to 1, except when a is equal to 0. The next law, a to the power minus n is equal to 1 over a to the n power. The example, 4 to the power negative 2 is equal to 1 over 4 squared. The next law, 1 to the n as the power of a is equal to the nth power of a. In the example, 8 to the power 1/3 is equal to the cube root of 8. The next law, a to the power m divided by n is equal to the nth root of a to the m power. The example to illustrate that, 27 to the power 2/3 is equal to the cube root of 27 squared. The last one, if a to the n power is equal to a to the m power, that is the same base, the power is different, then we conclude that n is equal to m. The example to illustrate that, 3 to the 5th power is equal to 3 to the 2n minus 1. The base being 3, we conclude that 5 is equal to 2n minus 1. Here are some examples taken from past CXC papers. The first one, simplify 3c squared times 3c cubed. The answer is 9c to the 5th power. 3 times 3 is equal to 9. C squared times c cubed would be c to the power 5, that is 2 plus 3. The second one, evaluate 12b to the 7th power divided by 4b to the 5th power. 12 divided by 4 is equal to 3. b to the 7th divided by b to the 5th, you subtract the powers, that is 7 minus 5 will give us 2. So we'll end up with an answer, 3b squared. The third one, 81 to the power half times 27 to the power minus 1/3. This will give us, we'll convert 81 to the same base, which is 3, and that will give us 3 squared times 3 to the 3rd power all to the power minus 1/3. Using the laws of indices, when we are multiplying the numbers with the same base, we add the powers. So we use the base 3, and it will be 2 minus 1, which will give us 3 to the 1st power, which is just 3. The fourth one, solve for x in 9 to the 2x is equal to 1 over 27. We can rewrite all of this to a common base, which is 3. So we'll have 9 written as 3 squared, 2x remain as the power, and we can write 1 over 27 as 3 to the minus 3 power. The left-hand side will give us 3 to the 4x power equal to 3 to the minus 3. Equating the indices, we'll have 4x is equal to minus 3 and have x is equal to minus 3 over 4. The fifth example, evaluate 5 cubed times 5 to the minus 2 power. That will give us 5 to the 3rd power minus 2, which will give us 5 to the 1st power, which is just 5. Here are your problems for today. The first one, calculate the value of 9 to the power a half times 8 to the power 2/3 times 4 to the power 0. This one is taken from CXC January 2005. The second problem, simplify 4c squared times 3c to the 4th power divided by c to the 3rd power. This one is taken from CXC January 2002. Here are the solutions to the problems given in the last lesson. This is your first one. You're asked to solve the pair of simultaneous equations. Y is equal to x plus 2, your first equation. Y is equal to x squared, your second equation. We substitute y is equal to x squared in the first equation, and we have x squared is equal to x plus 2. Take all the terms to the left-hand side That will result in x squared minus x minus 2 equals 0. And we can factorize the left-hand side as a trinomial, which will give us x minus 2 times x plus 1 equals 0. If we solve each factor as a simple equation, we will have x is equal to 2 or x is equal to minus 1. And now in substituting we have when x is equal to 2, we'll have y is equal to 4 because we notice that y is equal to x squared. When x is equal to minus 1, y is equal to 1. This is your second problem. Solve the pair of simultaneous equations. 2x plus y is equal to 7, your first equation. X squared minus xy equals 6, your second equation. From equation 1, substitute y is equal to 7 minus 2x in equation 2. This will give us x squared minus x into 7 minus 2x equals 6. Clearing brackets, we have x squared minus 7x plus 2x squared equals 6. Take 6 to the left-hand side and simplify. We'll have 3x squared minus 7x minus 6 equal to 0. Factorizing the left-hand side, we'll have x minus 3 times 3x plus 2 equals 0, which will give us x is equal to 3 or x is equal to minus 2/3. Substituting, we'll have when x is equal to 3, y is equal to 1. And when x is equal to minus 2/3, we'll have y is equal to 8 1/3. This brings us to the end of today's program, CXC Mathematics in Focus.
Boys and girls, today we will continue to study the short story. There are several hundreds of excellent short stories in the many collections you may have come across in your classes at school. It is an absolute necessity that you read stories in order for you to write good stories. We will read a story in this lesson and another in the next lesson that will illustrate all the requirements that CXC desires you to meet. Now, listen carefully. First, the title of the short story, After 20 Years. And this is written by the famous story writer, O. Henry. You would have observed that each story can be clearly divided into beginning, middle, and end, and that each ends with a surprise. The modern short story builds its way and ends abruptly, but logically. For CSEC purposes, a short story is a set of closely related events that seek to resolve a conflict, a difficulty, a problem or situation. It can also be a series of interrelated details of a character that reveal why the character undergoes certain changes or why he acts as he does. You should obtain a copy of the two stories and study them carefully because we will refer to them from time to time. Short story 1, After 20 Years. The policeman on the beat moved up the avenue slowly. The time was barely 10 o'clock at night, but chilly gusts of winds with a taste of rain in them had emptied the streets. Trying doors as he went, he twirled his club with many intricacies and artful movements. Turning now and then to cast his watchful eye down the street, the officer, with his stalwart form and slight swagger, made a fine picture of guardian of the peace. The vicinity was one that kept early hours. Now and then you might see the lights of a cigarette store or an all-night lunch counter. But the majority of the doors belonged to business places that had long since been closed. When about midway of a certain block, the policeman suddenly slowed his walk. In the doorway of a darkened hardware store, a man leaned with an unlighted cigar in his mouth. As the policeman walked up to him, the man spoke up quickly. "It's all right, officer," he said calmly. "I'm just waiting for a friend. It's an appointment made 20 years ago." Sounds a little funny to you, doesn't it? Well, I'll explain if you'd like to make certain it's all straight. But that long ago, there used to be a restaurant where the store stands. Big Joe's Brady's Restaurant. "Until 5 years ago," said the policeman. "It was torn down then." The man in the doorway struck a match and lit his cigar. The light showed a pale, square-jawed face with keen eyes and a little white scar near his right eyebrow. His scarf pin was a large diamond, oddly set. 20 years ago tonight," said the man, "I dined here at Big Joe Brady's with Jimmy Wells, my best chum, and the finest chap in the world. He and I were raised here in New York, just like two brothers together. I was 18 and Jimmy was 20. The next morning, I was to start for West to make my fortune. You couldn't have dragged Jimmy out of New York. He thought it was the only place on earth. Well, he agreed that night that we would meet here again exactly 20 years from the date and time, no matter what our conditions might be or from what distance we might have to come. We figured that in 20 years, each of us ought to have our destiny worked out and our fortunes made, whatever they were going to be." "It sounds pretty interesting," said the policeman. "Rather a long time between meets, though, it seems to me. Haven't you heard from your friend since you left?" "Well, yes, for a time we corresponded," said the other. "But after a year or two we lost track of each other. You see, the West is a pretty big proposition, and I kept hustling around over it pretty lively. But I know Jimmy will meet me here if he's alive, for he was always the truest, staunchest old chap in the world. He'll never forget. I came 1,000 miles to stand in this door tonight, and it's worth it if my old partner turns up." The waiting man pulled out a handsome watch, the lids of it set with small diamonds. 3 minutes to 10, he announced. It was exactly 10 o'clock when we parted here at the restaurant door. "Did pretty well out west, didn't you?" asked the policeman. "You bet. I hope Jimmy has done half as well. He was a kind of a plodder, though, good fellow as he was. I've had to compete with some of the sharpest wits going to get my pile. A man gets in a groove in New York. It takes the West to put a razor edge on him." The policeman twirled his club and took a step or two. "I'll be on my way. Hope your friend comes around all right. Going to call time on him sharp." "I should say not," said the other. "I'll give him half an hour at least. If Jimmy is alive on earth, he'll be here by that time. So long, officer." Good night, sir, said the policeman, passing on along his beat, trying doors as he went. There was now a fine, cool drizzle falling, and the wind had risen from its uncertain puffs into a steady blow. The few foot passengers in that quarter hurried dismally and silently along with coat collars turned high and pocketed hands. At the door of the hardware store, the man who had come 1,000 miles to fill an appointment with his friend of his youth smoked his cigar and waited. About 20 minutes he waited, and then a tall man in a long overcoat with collar turned up to his ears hurried across from the opposite side of the street. He went directly to the waiting man. "Is that you, Bob?" he asked doubtfully. "Is that you, Jimmy Wells?" cried the man in the door. "Bless your heart," exclaimed the new arrival, grasping both the other's hands with his own. "It's Bob, sure as fate. I was certain I'd find you here if you were still in existence. Well, well, well. 20 years is a long time. The old restaurant's gone, Bob. I wish it had lasted, so we could have had another dinner there. How has the West treated you, old man?" "Bully, it has given me everything I asked for." "You've changed lots, Jimmy. I never thought you were so tall, by 2 or 3 inches. Oh, I grew a bit after I was 20. Doing well in New York, Jimmy?" "Moderately. I have a position in one of the city departments." "Come on, Bob. We'll go round to see a place I know of and have a good long talk about old times." The two started up the street arm in arm. The man from the West was beginning to outline the history of his career. The other listened with interest. At the corner stood a drugstore brilliant with electric lights. When they came into the glare of each other, each of them turned to gaze upon the other's face. The man from the West stopped suddenly and released his arm. "You're not Jimmy Wells," he snapped. 20 years is a long time, but not long enough to change a man's nose from a Roman to a pug. "It sometimes changes a good man into a bad one," said the tall man. "You've been under arrest for 10 minutes, Silky Bob. Chicago thinks you may have dropped over our way and wises it wants to have a chat with you. Going quietly, are you? That's sensible. Now, before we go to the station, here's a note I was asked to hand to you. You may read it here at the window. It's from Patrolman Wells." The man from the West unfolded a little piece of paper handed to him. His hand was steady when he began to read, but it trembled a little by the time he had finished. The note was rather short. "Bob, I was at the appointed place on time. When you struck the match to light your cigar, I saw you. It was the face of the man wanted in Chicago. Somehow I couldn't do it myself, so I went around and got a plainclothes policeman to do the job. Students, I hope you recognize the twist, the surprise ending in the story. On behalf of the team, Bibi Ali, Parmeshwar Lal, Ron Chichester, I'm Ingrid Fong, saying see you next time.
National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program in the series CXC Mathematics in Focus. In today's lesson, we'll be looking at relations and functions. In this lesson, we will look at relations and functions as they apply to mathematics. A relation is defined as a set of ordered pairs, example, 3, 2, 2, 7, 5, 8. The first coordinates of a set of ordered pairs are together called the domain of the relation. In the example given above, the domain contains the numbers 3, 2, and 5. The range of a relation is a set of all second coordinates. In the example given above, the range consists of 2, 7, and 8. A mapping is a pictorial representation of a relation. Here's an example illustrated for you. In the first loop, we have 3, 2, and 5. That will constitute the domain. In the second loop, we have 2, 8, and 7. That will constitute the range, or sometimes we call that the image. And on the right-hand side, we have this set of ordered pairs listed there for you. That diagram is called a mapping. A function is a relation in which each element of the domain is paired with exactly one element of the range, or sometimes we call the range the codomain. Here's an example of a function. We have the first loop consisting 1, 3, 5, and 7. The second loop consisting 4, 10, 16, 22. And we find that elements are matched from the first loop to the second using the relation 3x plus 1. So if you take the first example, 3 times 1 plus 1 is 4. So 1 is mapped onto 4. 3 times 3 plus 1 will give us 10. So 3 is mapped to 10. 3 times 5 plus 1 will give us 16. So 5 is mapped to 16. And 3 times 7 plus 1 will give us 22. So we have 7 mapped onto 22. Here is another example of a function. This function is the function x squared. In the first loop containing elements of the domain, we have 0, 2, 4, 6, 8, and 10. And in the right-hand loop, we have the numbers 0, 4, 16, 36, 64, 100. The second loop will be the range elements. So if we square 0, we have 0. So 0 is mapped to 0. If we square 2, we have 4. So 2 is mapped to 4. If we square 4, we have 16. 4 is mapped to 16. If we square 6, we have 36. 6 is mapped to 36. If we square 8, we have 64. So 8 is mapped onto 64. If we square 10, we have 100. So 10 is mapped onto 100. Here is an example of a mapping that is not a function. This mapping relation is square root. So we have in the first loop for the domain, we have 36, 49, 64, 81, 100. On the right-hand loop, we call the range. We have -10, -9, -8, -7, -6, +6, 7, 8, 9, and 10. Square root of 36 will be mapped on to two numbers. And you would have, if you follow the arrows, you will see from 36, we have two arrows going, one going to -6, one going to +6, because the square root of 36 could be either -6 or +6. 49, the square root of 49 will be -7, +7. So from 49, you have two arrows going to map 49 to -7 and +7. 64, square root of 64 is -8, +8, and you can see that following the arrow. 81, square root will be -9, +9. So your arrow's going to from 81 to -9, +9. Similarly for 100. We use certain notations when we are dealing with functions. We call this area functional notation. So a function can be expressed in three forms. The first one, f such that, and that's how it is read, f such that x is mapped onto 2x plus 1. The second one, f of x is equal to 2x plus 1, both representing the same thing. And so the third one, y is equal to 2x plus 1. For a given value in the domain, we can find its corresponding image value. In the function f of x is equal to 2x plus 1, a domain value of x equals 3 will give a corresponding image value of 7. And this is how we arrive at 7. F of 3 is equal to 2 times 3 plus 1. 2 times 3 equals 6 plus 1 will give us 7. If, however, we are given an image value and we are required to find the domain value using the function, then we have to manipulate the function to use its inverse. That's the reverse order. To do that, we need to examine how the function was composed in the first place. Let us check for the function f of x is equal to 2x plus 1. Here we use a diagram to show how the function is built. We have boxes, 3 boxes. X is in the first box, and this kind of device is called a function machine. So x is in the first box, and it is going through a process to reach the second box. Through that process, it is multiplied by 2. So 2 times whatever is in the first box, when it reaches the second box, it becomes 2x. Moving from the second box to the third box, we add 1. So when it reaches the third box, it is 2x plus 1, giving us a function that is equal to f of x equal to 2x plus 1, or can be expressed as y is equal to 2x plus 1. If we reverse that process, have the arrows turn the other way around, and if we add 1, the reverse or the opposite or the inverse of adding 1 is subtracting 1. The inverse of multiplying by 2 is to divide by 2. And we start with x from the right-hand box. X coming into the second box, the operation is saying subtract 1. So when x reaches the second box, it will be x minus 1. Moving into the third box, the second box must be divided by 2. So we'll end up in the third box with x minus 1 divided by 2. That result is the inverse of the function f of x is equal to 2x plus 1 and can be written as f inverse of x equal to x minus 1 all divided by 2. The inverse of a simple function can be found using this simple device. In a formal way, finding the inverse of a function is really to exchange the variables. As in the case above, changing the variables of y equal to 2x plus 1 will result in x is equal to 2y plus 1. That is, exchanging x for y. Now solving for y will give the inverse of the function, which is x minus 1 divided by 2. Here are some examples of some taken from past CXC papers. In the first column, we have functions, and in the second column, we have the inverses. F of x is equal to 2x plus 5. The inverse would be x minus 5 divided by 2. For the function 3x minus 1, the inverse would be x plus 1 divided by 3. For the function a half x plus 1, the inverse will be 2x into x minus 1. For the function half x minus 1, the inverse would be 2 into x plus 1. Note these below here. For the function 1 minus x, the inverse is the same as 1 minus x. And you can try it by exchanging the variables. The next one, if f of x is equal to x, the inverse will be x. When a function is 1 over x, the inverse is 1 over x. But in this last one, when the function is x squared, the inverse will be root x. Here is your problem for today. If f and g are functions defined as follows, f is such that x is mapped onto 7x plus 4, and g is a function such that x is mapped onto 1 over 2x. Calculate 1, g of 3, 2, f of negative 2, and 3, f inverse of 11. This problem is taken from CXC January 2007. Here are the solutions to the problems given in the last lesson. You're asked to calculate the value of 9 to the half times 8 to the 2/3 times 4 to the 0 power. 9 to the half can be expressed as square root of 9 times the cube root of 8 squared times, as I mentioned, 4 to the 0 power is 1. Square root of 9 is 3. The cube root of 8 squared is 4 times 1, and 3 times 4 times 1 is 12. The second problem, simplify 4c squared times 3c to the 4th power, all divided by c cubed. We can multiply the numerical values, 4 times 3 times c, and we use the laws of indices, so we'll have 2 plus 4 minus 3. We minus 3 because we are dividing by c cubed. When this is simplified, we have 4 times 3 is equal to 12, and the indices, the index will work out to be 3. That is 2 plus 4 minus 3, 6 minus 3, 3. This brings us to the end of today's program, CXC Mathematics in Focus.
Boys and girls, in this lesson, we will look at a story written by a CSEC student who won the Best Story Award in 2004. This story is based on a picture provided in the 2004 English paper 2. He hungrily gulped in the fresh air. The clean tang of the sweet smell of rain still lingered in the atmosphere, and his nostrils welcomed it. It was something he knew. All the lush vegetation around him blended into a monotonous shade of green. Everything seemed so clean and new, almost rejuvenated. Although great big tufts of grey lurked around ominously in the sky overhead, he felt calm, serene. Perhaps today he would remember which way home was. He had been walking for days, it seemed. His wet suit hung tiredly from his gaunt body. And once again he smothered the pangs of hunger assaulting his stomach. Noticing a speck at the end of the long winding road, his heartbeat accelerated. Was this home? He pushed his old bones to walk a little faster. Maybe he would soon be home. As he got closer and closer to the end of the road, the speck began to take on a definite form. And with a laden heart, he realized that a shack was the only thing that stood out among the blur of green. On reaching the tiny shack, obviously abandoned since it was overwhelmed by clinging green vines, he suddenly felt tired. All his strength seemed to be sapped away by an unseen force, and he lowered his tired form to the grassy ground. Cradling his legs to his chest, he rocked back and forth, trying to draw some comfort from the soothing movement. That was the way Susan found him. His hair stood up in all different directions. Wrinkled creases marred his brow, and his whole posture was that of a frightened, confused man. A twig snapped under her feet, and he suddenly jumped up, his bones creaking in protest. The young woman before him smiled, a smile that seemed to be a brilliant beam of sunshine in his otherwise melancholy world. Her rich chocolate brown eyes were filled with warmth and understanding. These eyes mesmerized him. They seemed to reach out to him in an unspoken yet thankfully loud message. He found himself offering up one wrinkled, trembling hand, and without a thought the young woman grasped it, hung onto it as though it were something to be treasured, and he felt the warmth of her hand spread all through his entire body. That warmth, combined with the warmth of her smile and the warmth in her beautiful dark eyes, seemed to banish all the cold loneliness and bewilderment in his heart. Suzanne found her eyes welling up with tears and tried her best to remain standing. This time, he had been gone for so many days that it seemed like a miracle that he was alive. Home? He asked, his voice sounding as trusting and as innocent as that of a child. Yes, home, Grandpa, she reassured him as she led him slowly out into the road where her car was parked. His bearded face split into a grin as he spotted the car. He was so very thankful that he did not have to walk again. He was completely fed up of walking. As Susan saw his grateful smile, once again cursed the disease that had robbed her grandfather of all his intelligence, vitality, and all his control of life itself, leaving in its wake this scared, confused shell of an old man. Alzheimer's, the disease that her grandfather, a renowned doctor, had tried to fight but had lost. Now, boys and girls, having listened to the story in the first lesson and this story, you may be wondering if you could possibly write stories of such excellence. Of course you can. But as we pointed out before, you must develop the habit of reading stories regularly. There are several basic ingredients that are necessary if you are going to produce an excellent short story. Commonly, these are called elements of the short story. And some of these are plot, characterization, setting, point of view, narrative techniques, effective language. In this lesson, we would wish to focus on the first two. Plot. Very often, this would be used as of the others are, without a clear understanding of what it means to a student writing the CXC examination. Many students rattle off the list of elements of short story writing, but they cannot connect these to specific stories. By the term plot, we mean the series of closely related incidents or details that culminate in the final incident or result, which very often comes as a surprise, an unexpected happening or motivation. One common error made by students at this level is that they relate a series of events, but these are not connected in a logical fashion. Very often, these are separated, isolated incidents. Stories made up of these kinds of incidents are called episodic or pedestrian, and often end up with less than 1/3 of the marks assigned to the question. As an illustration, suppose John meets Jane by accident in a minibus and is attracted to her. He invites her to a cup of coffee at Demico. On 4 other occasions, he invites her for lemonade, tea, Coke, and Malta at different venues, and they chat about the weather, cricket, VAT, and such like. And every meeting is a replica of the previous meeting, except for the venues. By this time, you would have reached 400 or 450 words, and you end your story. This would be a pedestrian or episodic story that leads nowhere. If, on the other hand, over the 5 incidents, John flatters Jane, she introduces him to her family who accepts him and proposes to her, you are on the way to writing a story with a plot. She's ecstatic and or on the verge of saying yes when she discovers that he's a habitual con man and terminates the relationship. Surely you now have a plot, not unrelated episodes. As an exercise, you can use any of the topics we had noted in Lesson 9 and experiment with creating closely related incidents or details culminating in a final action or incident. Another useful exercise you can do is to take any of the stories you have read or studied and try to break the story down into a series of incidents. Very often a story at CSEC is really one major incident comprising a number of details or smaller incidents. The story after 20 years is really one major incident made up of a series of supporting details or incidents. So ensure that you master the skill of identifying, analyzing, and creating plot in short stories. You may find this a useful guide. Incident 1, 2, 3, 4, 5. So students, until the next time, I'm Ingrid Fong saying goodbye on behalf of the team, Lady Ali, Parmeshwar Lal, and Ron Chichester.